Okay, this is 2021 Ijmb Physics Mechanics. You have to stick to the end of this video because I'll be taking my time to not just answer the question but to give you the breakdown and the steps you don't have to skip in order to get the full score that will be allocated to each of the question. So stick to the end of this video. Not only that, before you proceed, please go drop a comment at the comment section, and not only that, like the video and also share the video to other Ijmb students that are that are not aware of this particular channel. Now look at this question, section B, mechanics. It say attempt one of the questions from this section. Now what will be happening is that anything that has to do with definition, you have to see it at the end of the video. I'll be giving anything that has to do with definition. So that's why I'm advising you to stick to the end of this video. What are vector and scalar quantities? Which class do momentum, current, energy, acceleration belongs to? Vector quantity, it's really simple to define. Vector quantities are quantities that have magnitude and direction. We are done with this. And we also have scalar quantities have magnitude but no direction. Which class do momentum, current, energy, acceleration, and mass belongs to? Momentum belongs to a vector quantity because momentum is the product of mass and its velocity, and velocity there is a vector quantity because velocity is the change in displacement over time, and displacement has to tell you that there is a direction that has been allocated. So current is a scalar quantity, has no direction. Energy, it's a vector quantity. Acceleration is a vector quantity, and mass is a scalar quantity. Now, look at the second question. State the principle of conservation of linear momentum and show how it follows from Newton's law of motion. By the end of the video, stick to the end. You're going to see the answer to this. Then I'll be solving this. But now I will move down to question 12. State Kepler's law of planetary motion. Don't worry about this. You'll see it at the end of the video. Now, let's look at question 2. The planet Earth remains in its orbit at a constant speed v around the sun. Show that the mass of the sun is given by v cube over gw, which is the angular speed, where g is the universal gravitational constant and the angular speed is the earth, w is the earth's angular velocity. State all the assumptions made. 3. Calculate the mass of the sun if the radius of the earth orbit is 1.5 multiplied by 10 power 11 meter. Let me start with this question before I dive into other question. Okay, this is where we have the question here. Now I'll advise you, if you have not watched all my other videos on gravitational Newton's law of gravitation and the relationship between G and big G and the derivation of centripetal force, this video or this tutorial may not be too helpful for you. You just check down the description below and you can click on the videos, watch them before coming to watch this one. Let's look at the question. The planet Earth remains in its orbit, constant velocity. Let me put a diagram to this. This is the very first step. Now look at the diagram. If you had followed my last video on Newton's law of gravitational force, there's a force of attraction between the Earth and the Sun, and the Earth is revolving around the Sun. And the reason why the Earth still keep revolving around the circular part, it's because there is a centripetal force that keeps it on this circular motion. And because of the presence of the centripetal force, we now have that centripetal force is equal to the force of gravity. And we know that centripetal force is given as mw square r, and gravitational force is g, mass of the sun, gravitational between the mass of the sun, mass of the earth, and the radius between them. Now, we now have this. We can now cross multiply that the centripetal force which keeps the earth from revolving is equals to w square r multiplied by r square is equal to g, mass of sun, and mass of the earth. We can now say that ME is equal to W square arrow cube, arrow 2 multiplied by arrow power 1 is going to give us arrow cube to GMS ME. Now, if you look at the question, they say show that MS is equal to this. So we are going to see how we can allow the mass of the sun to be alone, and on doing that, we divide through by ME and we divide through by GME. On dividing through, we have G will cancel out, ME will cancel out. And in this place, ME had to cancel out this. I'll be having that MS from here, that MS, which is left, is equal to the angular speed multiplied by the radius in cube over G. Now, don't forget that V is equal to WR, the relationship between linear speed and angular speed. Now, we can now say that let's make arrow the subject of formula. On doing that, we are going to be dividing through by the angular speed. When we divide, the radius becomes V over W. So what happened now? We are going to plug it in this equation we have here. So wherever we see arrow, we are going to be putting V over W. So MS, mass of the sun, is equal to W square. Where there is arrow cube, it becomes V over the angular speed power 3 because it's a cube over G. And on having this, we could now open the bracket, and on opening the bracket, we have that MS is equals to W square V cube W cube. We've now opened the bracket divided by G. Now, look at this very well. This equation is the same as this, but we have a W cube here, we have a W square. So this W square will cancel out with this W cube and we'll be left with 1 W. And from that, we now have that MS is equal to V cube divided by W divided by G. And we cannot take the inverse. On taking inverse, we are going to be having V cube over W multiply. On taking inverse, the division sign will change over G. And we now have that the mass of the sun is equal to V cube over G angular speed. We have shown that this is equal to this. Now look at the latter part of the question. State all the assumptions made. The assumptions made here is that there's a relationship between linear speed and angular speed, of course, here from this part. And the other assumption is that from Newton's law of gravitational force, there is the relationship that tells us that gravitational force is equal to this. And we concluded by arriving at this, where this is the mass of the sun, this is the linear speed, this gravitational constant, and this is the angular speed. Let's look at question 3. They say calculate the mass of the sun if the radius of the Earth orbit is 1.5 multiplied by 10 power 11. Please take note, it's power 11. From our question, let me clear up the space so that we can look at question 3. Before we look at question 3, if you are really watching this video currently and you have not subscribed, you have not done well, please do me a favor by subscribing. And that will boost up my energy and enable me to create more of this content, answering most of the past questions that you find difficulties with. Let me clear up the space. So from the relation that says that centripetal force, which is mw squared r, is equal to the gravitational force, which is G, mass of the sun, mass of the earth, divided by their square root. So all we have is we're going to cross multiply, which is going to give us that centripetal force multiplied by r squared is equal to G mx me. And since we are looking for the mass of the sun, we will be dividing through, but let's finish up with this. W square r times r squared is going to give us r cube is equal to G ms me. Since we are looking for ms, we'll be dividing through by G me so that ms will stand on its own. So G me. So this will cancel G's, and the mass of the earth will cancel the mass of the earth. And here the mass of the earth will have to cancel this out. So we'll be left with the mass of the sun, which is given as w square root cube over g. Now we've been given this. Now if you take note, we have been given that the radius of the earth is given as 1.5 power negative 11 meter, and we know that g is given as 6.67 power negative, sorry, this one is power 11, not negative, power 11. There's no negative sign in this. Let me have to clear this up. I has already been giving the question, so let me just keep this for now. Now don't forget that this w is equals to 2 pi over t. Now if you don't know that w is equals to 2 pi over t, you have to go and watch my video on the relationship between linear speed and angular velocity. That is the relationship between v is equals to wr. Now since this has been given, now we are looking at what then could be t. T is equal to the period it took the earth to revolve around the sun, and for the earth to revolve around the sun, it takes 365 days for it to revolve around. Okay, 365 days. Now we cannot be using time. We cannot be using time as we cannot be using day as when it comes to using time. So sorry, I got distracted by the call that came in. We cannot be using days when it comes to time. We have to convert it to seconds. So this the simple thing. You know, from this is how to do the simple conversion. From second we get to minute. From minute we get to hour. From hours we get to days. Now we're using this plugin to do the conversion, and we know that it is 60 seconds and make 1 minute, 60 minutes make 1 hour, 24 hours make 1 day. Since we're going to be using this for here, since we already have the day is already there, so from days we move to hour, from hour, so, and it was 24 hours that make a day, multiplied by 60 minutes that make an hour, multiplied by 60 seconds that make a minute. So on getting this, we're going to be having that our t is equal to, if we press this in a calculator, we're going to have that t is equals to 3.14 times 10 raised to the power 7 seconds. Okay, if you do your calculation where it could be 3.15 times 10 raised to the power 7 seconds, easy. So we can easily write this down here and keep the value while we see how we can arrive before we use this plugin. Since we've gotten t to be 3.15, in some cases 10 raised to the power 7 seconds. Now this will happen wherever we see w, we substitute this into it. Now from this equation, I say mx is equal to w square, which is 2 pi w square. W is 2 pi over t, so we square it. Okay, all divided through by, we have an arrow cube there, divided by g. This is what we have. Then opening the bracket, we'll be having ms equals to 2 square pi square over t square divided through by g, and we have something here, arrow cube. So ms is equal to 2 square is 4 pi square divided by t square arrow cube. Okay, we can now say divided through by g over 1. So we can take the inverse. On taking the inverse, we'll be having that 4 pi square divided by t square arrow cube multiplied by 1 over g. So this relationship will end up that ms is equal to 4 pi square arrow cube divided by gt square. Now since we've gotten this and we have known what G as 6.67 times 10 to the negative 11, and we know what this one is power 11, and we know what T is, and we know what our radius is. Our T is given, our radius, and pi, we know that pi is equals to 3.142. We can therefore put in the plugin and solve for the M. So we proceed to do the plugin. Please subscribe. Is 3.15 or 10 raised to power 7 seconds. Now let's do the plugin. We just have to avoid this. So mx equal to 4 multiplied by 3.14 142. Okay, but the 3.142 is squared multiplied by array is given as 1.5 times 10 raised to power 11 all squared all raised to power 3, okay, divided by 6.67, which is the G, times 10 raised to power 11 multiplied by the T square is given as 3.15 times 10 raised to power 7 by this. Now, most of the time, this is where most of the students make mistakes. They will love to just carry this and put it in their calculator and boom, get the answer. Now, when solving A-level problems, they just want to get the fact that you understand your simple mathematics. So you don't do that. Just follow me and I'll break this step down for you. This is what happened. Mass of the sun is equal to 4 multiplied by 3.4 multiplied by 3.4. Let me bring out the calculator. This is what we're going to be having. Okay. 3.142. Okay. Multiplied by, I know it's power 2, 3.142. This is what we're going to have, 9.87. So approximately, I will just give it at 9.9. Okay. Multiplied by 1.5. 1.5 multiplied by 1.5 multiplied by 1.5. We discovered that we'll be having 3.375. So I'll just approximate it and make it 3.4. Okay. This I've just done for this because this is going to be power 3 and this one is going to be times 10 raised to the power 11 times 3. Okay, when this is power 3, we are going to be having 3.4, what we've just done here. So we are going to now divide it all through by 6.67 multiplied by 10 raised to the power 11. Okay, multiplied by 3.15 is just going to be the same thing as 3.15. Now this bracket, we do it like this: 3.15 square times 10 raised to the power 7 multiplied by 2. Now this is what how it means to open this bracket. So when we do 3.15 square, this is what we will arrive at. We'll be arriving at 9.9. Okay, multiplied by this. Now let me have to clear this up first. We're going to be having 9.9 on opening this bracket. 3.15 square is going to give us 9.9 times, now it's going to be 2 times the power here 7 is going to be us 10 raised to the power 14, and we can proceed. Now we now have that. Let me pick a different color. We now have that the mass of the sun is equal to 4 times 9.9 times 3.4. Okay, times, now we can now open this bracket. This now, if we multiply this by this by this, we end up having 138.6. 138.6 multiplied by, now on this aspect, 3 times 11 is going to give us 10 raised to the power 33 divided through by, okay, we come to this downside. We are going to be multiplying this by this, which is the number, and forgetting, and we won't multiply the powers. And please don't forget, this is negative 11. Please don't forget, this is negative 11. So look at it here, it is negative 11. So we are going to be having, when we multiply this by this, we end up having 66.0. You know, I normally approximate them to the nearest thing, and we're going to be left with the powers 10 negative 11 times 10 raised to the power of 14. So this will happen. We will now say that ms is equal to, we are going to be dividing 138.6 by 66.0. On doing that, we're going to have 2.09. 2.09 multiplied by 10 raised to the power 33 divided through by, we still have 10 raised to the power minus 11 times 10 raised to the power 14. Don't forget, we are going to be adding the powers because of the multiplication sign. And on adding that, we are going to be having 10 raised to the power minus 11 plus, we have what, 14. And on doing that, it's simply going to give us 10 raised to the power 3. Okay? And since it's going to give us 10 raised to the power 3, we can simply write this as m raised to the power x equal to 2.1. I have approximated again, times 10 raised to the power 33 divided by 10 raised to the power 3. Now, we can still rewrite this equation as this 2.1 times 10 raised to the power 33, okay, divided by 10 raised to the power 3. Okay, you should know that when there is a division sign like a raised to the power x divided by a raised to the power y, we're going to be having a raised to the power x minus y. So on doing that, we're going to be having 2.1 multiplied by 10 raised to the power 33 minus 3. Okay, on subtracting, the mass of the sun becomes 2.1 times 10 raised to the power 30 kilogram. This is how to solve problem. If you don't make this your problems and try to say you can bring them down to the simplest form, you will be having issues just pressing your calculator. And now, if you are still watching this video and you are yet to subscribe, you are not encouraging me, please do me a favor by subscribing. Now let's dive into the next question. Now here we are in our blackboard. Now, define centripetal force and deriving its expression. Centripetal force is that force that is needed to keep an object moving in the circular path. Okay, that is centripetal force. Now, if you are watching this video and you've not watched my video on the derivation of centripetal force, you can be a little bit confused. So you go down to the description and you take a view of the video before coming back. Now, centripetal force, you should not forget that force, it's defined as mass times acceleration. Okay, but when we're talking about centripetal force, we're looking at a body carrying out an acceleration, a centripetal acceleration, that is a body, an object moving around a circular path. Okay, moving around a circular path, and it is being kept in that circular path by the action of centripetal force, and because of that, there's a centripetal acceleration. So we shouldn't forget that from this formula we have the acceleration, but acceleration is equals to change in velocity over time. Okay, and acceleration can also be written as velocity change in theta over time. Now don't be confused. You can only be confused if you have not watched my video. Now on getting this, we now discover that acceleration can be written as velocity times change in theta over time. But we have that angular speed is change in theta over change in time over time. Okay, and we can plug this in here, and doing that, we're going to have the acceleration is equals to VW. That is where we see change in theta here, we replace it by the angular speed W. And don't forget that the relationship, but we still have that, but the relationship between angular speed and linear speed is given as V is equals to WR. So we can easily make W subject to formula by dividing through by R, and dividing through by R, we'll be having that the angular speed becomes v over r. So we take this and we put it here, and on doing that, we're going to be having acceleration is equals to v. Where you see w, we put v over r, and acceleration then it becomes v times v square over r. Now from ft is equals to ma. Now we can now replace our a with this. So centripetal force is equal to mv square over r. We've done a replacement. We can also deduce that centripetal force, we can still say ft is still the same thing as w square r, using v is equals to wr. How do we go about this? When we see v from this equation up here, we replace it with wr, and we have that ft is equals to m. When we see v, we replace by w. When we see v replaced by w square, is going to be wr square over r. Okay, we replace the w with v by this wr, and on opening, we're going to be having that ft is equal to m w square r square over r. And this one of this arrow cancel out with this arrow, we're going to have that centripetal force equals to m w square r. So we've gotten another relationship for centripetal force. So if you're asked in your exam, this is what you're expected to do. Now look at the second question. A particle is projected upward at an angle of 60 degrees, okay, to the horizontal, and with a velocity of 50 meters per second. Calculate the maximum height reached. Okay, and reached by the particle, and the range. To calculate maximum height and range and derive the needed relation. Now let's solve for this. Don't forget that the formula for maximum height. Now let me clear up this space. Maximum height formula is given as u square sine square theta over 2g, if you recall. And we know that g is equal to 10 meters per second. And we know that u is equal to 50 meters per second. And we know that the angle theta is equal to 60 degrees. So we can now plug in this, and h equal to 50 square multiplied by sine 60 square divided through by 2 multiplied by 10. So h equals to 50 square is going to 2,500. Press your calculator. 50 times 50 is going to be 2,500. Let me pop up the calculator so that we can verify this. So we're going to be having 50 multiplied by 50. Multiplied by 50, and you get there, we get 2,500. So now let's proceed. And sine 60 is equal to 0.866 now square. So if you can use the calculator again, you see that sine 60, this is sine 60, 0.866. Now divided through by 2 times 10 is 20. So h max is equal to 2,500. So 0.866 square is given as 0.75 divided through by 20. Now we have that h max is equal to, when we multiply this, we are going to be having 1,875 divided through by 20. So h max is going to be 93.75 meters. Now for the range is given as u square sine 2 theta over g. Now we just do the same plugging, and arrow is equal to 50 square, which is a u, multiplied by sine, okay, 2 times 60 degrees, okay, 2 times theta, 2 times 60 degrees over 10, and the range becomes 50 square, which is 2500, multiplied by sine 2 times 60 is going to give us 120 degrees, divided through by 10. So the range becomes 2500 multiplied by sine 120 degrees. Let's look at sine 120 degrees. Okay, sine 120 degrees is going to give us 0.8662 times 0.866 divided through by 10. So when we multiply this, we're going to be having 2 times 0.866 0.86 times 2500 divided by 10. On doing this, we're going to be having 216.5 meter. Now, here comes the next question. Derive the needed relationship. Now, what will come to the back of your mind? The needed relationship is what you've used in solving the question. That's what you are going to be deriving. On means that we're going to be deriving the formula we used in solving the maximum height, and the formula we used in solving the range. Let's look at deriving this formula. Now, I told you, you don't derive any formula without a source. So as students, A level, you're expected to put down a diagram like this. Okay, and we have H max, make it rough, and we have this as U sine theta. Okay, and we have this as U cos theta, kt, and we have this as the Y, and we have this as the X, and this is the range. Okay, this is the range, and we have an angle theta suspended here. Now we have this object moving in this part. Okay, this object moving in this part, and get to this point. Now, how do we now derive this? Now, from the second law of motion that say s is equals to ut plus half at square. Okay, we know that for the maximum height, which is want to derive at here, the maximum height, which is the distance h, x will equals to h. Okay, and u is equals to u sine theta. Okay, that is u, and we know that the time taken to reach maximum height is given as u sine theta over g. The time taken for it to get to this maximum height is u sine theta over g, and acceleration is given as negative g. Okay, so we cannot do a plugin. Now what we have now, we are going to be having that h is going to substitute all this value into this equation. H is equal to, what we see u, we put u sine theta, okay, multiply by the time of flight, which is u sine theta over g, okay, minus, since acceleration is a negative sign, we're going to change this to minus half, okay, a minus half g, okay, since, and multiply by, we have this u sine theta, which is the time, over g square. Okay, should not be confused, this is for the t square. So h becomes u sine theta times u sine theta is going to be us u square sine square theta over g minus half g, okay, multiply by, we're going to open this bracket, and opening it, we're going to have u square sine square theta over 2g. Now this 2g can cancel this g out, and we'll be left with only 1g. So h becomes u square sine square theta over g minus, sorry, this is g square, and when it cancel out, when we, not 2g, this is g square, when we cancel out, it becomes 1g minus half multiplied by u square sine square theta over g. So we can know that this can be written as 2 times g. This can be, this part of the equation I'm written as u square sine minus u square sine square theta over 2g. So we're going to be taking LCM for it. And doing that, we're going to be having an LCM between g and 2g. Now I've rewritten this thing as this. So the LCM becomes 2g. 2g divided by g, we're going to be left with 2. So h is equal to 2g divided by g. 2g divided by g is going to be 2u square sine square theta minus, now 2g divided by this 2g here, and we're going to be having nothing, so it's going to be 1. So it's going to be minus u square sine square theta. So if you subtract this, this from this, we're going to be left with, let me clear up this space. We're going to be left with h is equals to u square sine square theta over 2g. That's for that. Then let us look at range. Now let's look at the range. From the diagram, we can see that range, we can use that r is equals to uxt. And we know that where ux at the horizontal is ux is equals to u cos theta, and t, the time of flight, which is 2u sine theta over g. Okay, this is the time of flight. So we can now just plug in that r is equals to u cos theta, okay, multiplied by 2u sine theta over g. Now we can now rewrite this equation as r equal to, we now have u square 2 sine theta, or multiply 2 sine theta cos theta. I had to arrange them over g, but 2 sine theta cos theta is given as sine 2 theta. You can now say r can be written as u square sine 2 theta over g. This is how to derive this particular equation. Let's look at the next question. If you know this video is helpful, please give it a thumbs up, comment, and also subscribe. It will enable me answer more and more of your past questions. Now look at the question. Before we get there, let's look at the question paper. Now look at the question paper. We'll be looking at question 11 II3. A stationary, because the two I have promised to already put it at the end of the video. A stationary nucleus of mass 24 units emits an out. Let's just look at how we can solve the problem. Now if I'm to advise students on mechanics, now if you look at question BI, divine moment of inertia, write down the expression of moment of inertia. For the sake of this video, I'm going to be making a video on this so that I can keep the video length short. It's because it's already getting too long and I don't want it to exceed this time. So I'll be making another video. But if I'm to give an advice to any A-level student, I would love you to avoid this topic. It's not really necessary. If you're acquainted with the ones we are doing and you master it, I think this topic are not complex like moment of inertia and its calculation. But nonetheless, I will still be making a video on that. Anyone that is more simpler for you, you just get yourself acquainted with that. But for my students that I'm coaching, I will ask them to avoid this topic and concentrate on the topics of really look at. But without wasting time, let's look at the next question. Now, this was a stationary nucleus of mass number. And power in physics is that you should be able to visualize the question and bring it out, make the interpretation. Now, when we're talking about nucleus, it means we are going to be having something like this. This nucleus is stationary. And without wasting your time, you may not really understand the solving of this problem except you've watched my video on kinetic energy on explosive force. Kinetic energy due to explosive force. You have to go and check out the video, look at the description below, and you have to watch out the video before coming back to this. If not, you may not really understand what was done here. In the video, I had to explain Newton's third law. So this question has to do with Newton's third law. And Newton's third law says that for every action, there is opposite and equal reaction. That is, for every action, there is opposite and equal reaction. An example of such for Newton's law is talking about the repel of gun, but I'm not here for that. If you really want to understand this, please go and check out on my video on the kinetic energy due to explosive force. Now let's continue. Now, a nucleus of mass number 24 units. Please, here's where student gets it wrong. 24 units. Unit is just a number, but the issue that they have told you mass number, it means this is 24 kilogram, because the SI unit of mass is kilogram. Emits an alpha particle of mass number 4 units. Okay, it emits an alpha particle of mass number 4 units. This mass is 24. It means what was emitted was not as large as this. Okay, of 4 kilogram. Okay, and with a velocity of what, 3 times 10 raised to the power 8 meter per seconds. And it has a kinetic energy. It has a kinetic energy given as 6.4. Okay, 6.4 times multiplied by 10 negative 12. 10 negative 12. Okay, this is the values. Now this is the particle. Now momentum, initial momentum is equals to final momentum. And momentum is given as the product of mass and its velocity. So for here, this mass, let's take this as the big M and the velocity as the big M, is equal to 0. Why? Because the mass is given and the velocity here is 0. So if I multiply by 0, we're going to be having 0. Okay? So for here, we have that the momentum should be a sum of mv. We're given mass and we're given velocity. For here, the momentum is 0. But from Newton's law, that momentum, initial momentum is equal to final momentum. That's from Newton's third law. So what we have here now is that, which is the initial, is equal to mv. So we're going to be having this. But now, if you have really watched my video on a recoil gun, when this emits this, now for every action that is equal and opposite reaction, it means there is a tendency that this went back with a velocity. Okay, and for it to go back from this cardinal point, look at this cardinal point, we have a plus, a minus, a plus, and a negative sign. Now for this to repel backward, it means we are going to be having a negative mv. So because of this repulsion, this is going to give us a negative mv because of the repulsion of the nucleus. And we are going to be having this as 0, which we make already 0, is equal to mv minus. So taking this to the other side, we're going to be having mv is equal to this. Now, we know that m here is 24, and the velocity we don't know. That's what we're looking for. Calculate the velocity is equals to, and the mass of m here is given as 4 multiplied by the mass, the velocity, which is 3 multiplied by 10 power 8. So we are going to be dividing through by 24. On dividing through by 24, we arrive at 24 will cancel out 24. We are arriving at v is equals to 4 multiplied by 3 times power 8 divided by 24. So 4 will cancel out 24, will cancel out itself 1. 4 will cancel out 24. Now we're going to be having 0.166. I can now approximate it to 0.17 or 0. Precisely I can say 0.2. Now we now have that v is equal to 0.2 times 10 raised to power 8. Okay, and I can still rewrite this as 2 times 10 raised to the power 1 negative 1 times 10 raised to the power 8, and I'm going to have 2 times 10 raised to the power negative 1. I'm going to add the values plus 8. Okay, and I'm going to have 2 multiplied by 10 raised to the power 7, okay, meter per seconds. That is the velocity of the stationary nucleus. Okay, now since we now have that the velocity of the stationary nucleus is given as 2.0 times 10 raised to the power 7 meter per seconds. Next question is calculate the velocity and kinetic energy. Calculate the kinetic energy. Let's calculate the kinetic energy of the recoiling nucleus. Now this is what will happen. We say that kinetic energy of stationary nucleus which recoil is equal to half mv square. So we are going to be having half multiplied by the mass is already given as 24, and the velocity of which we found here to be 2.0 times 10 raised to the power 7 meter per seconds. Okay, now there's no need of putting a unit. We can now square them. Squaring it, we're going to be having that half multiplied by 24 times 2 square multiplied by 10 raised to the power 7 times 2. If we open the bracket, the kinetic energy is equal to half multiplied by 24 times 4 times 10 raised to the power 14. If you look at this very well, we can now use our calculator, and this will have half is 0.5 multiplied by 24 multiplied by 4, and we end up having that the kinetic energy is 48 times 10 raised to the power 14 joules. What about the kinetic energy of the alpha particle? Is given as half mv square. Following the same method, we can say half multiplied by the mass multiplied by its velocity, which is 3 times 10 raised to the power 8, and we square it. So on solving for this, our final answer becomes, let's see, half multiplied by 4 multiplied by 3 square times 10 raised to the power 8 times 2. Okay, and if we do this all, we're going to be having 18 times 10 raised to the power 16 joules. So these are the different energies, kinetic energy, that was obtained. Now we'll be looking at the answers to the theory part of the question that has not been involved with calculation. But please, if you know this video was helpful, I would love you to subscribe, and most importantly, drop your comment. It is your comment that tell me where you may be having challenge, or if you really love the video, you say, sir, please, we need more of this content. What I'm trying to say is that when you comment, it is from your comment I will know what to be doing next. Is it that you want me to make more videos on your past question, or you want me to make more videos on any topic? Just drop your comment. Also like, share as part of the sacrifice, share the video, and also subscribe. Very important. And let's look at the answer to the other questions. Please do not forget to subscribe.